Now let's see how we can use the smoke simulation or pyro simulation to make our these particle drive the animation or to drive this particle simulation. And you know that if we go back in here, if we were to create an a velocity volumes, and in here as you can see we are working with these volumes, we are building these volume velocities and we are importing them inside of the DOP.NET to make our these particles move. So in here I can build an a pyro simulation or smoke simulation, and pyro and smoke simulation, they will too have an a velocity volume, which means we can import the velocity volume in here, and that way we can drive or these particle simulation with the smoke simulation. So let's go back, and in here I'm going to just remove all of these noises, all of these nodes that we had just created. Let me remove this visualization, and in here first let's see that before that we were using this helix node, and onto the helix, and here you can see we have this option to export the tangent. And in here let's say if you want to create your own line, let's say I'm going to add and draw my own curve. So in here I'm going to type a curve node. So let's add this and view this, and when the node is selected, hover over to the viewport and press enter, and that way we have this curve tool manipulator. And in here I can just start drawing my own line, and right now we are using this as a polyline, and I can confirm if I bring up the parameter, and here you can see we have the primitive set to polygon. So in here I'm going to just undo all of my operation, and in here I'm going to just draw a Bezier curve, which means I can just press and hold, and that way we have this Bezier handle to make out this line smooth. And in here I'm going to just my own random curve and press enter to complete your operation. And in here let's say we have this hand drawn curve, and this curve if you might have imported from other software, and you want to create the n attribute, and because of the curve I think we have the output attribute, and in here we have this option to enable the z-axis, and we are creating this tangent attribute. If I were to middle mouse button, we have this tangent. For visualization I'm going to just change this to n, which means that I'm creating the normals, and if I were to middle mouse button, and here you will see we have these normals, but because of the weird points, let me make this hide and enable the points, and here you can see because of the Bezier curve we have these weird points, and that is why we have this weird visualization. And to fix this I can add a resample node, and resample node will going to resample our line. So let's go into the resample, and here as you can see we are resampling our this line into an even distribution of points, and I can adjust this by changing the length to create more or less. And in here you will see that we are adjusting the length. So in here if I were to enable the point normals, and here you will see that our this is actually inheriting these normals because we have onto this output curve. But if you do not have this option, let's say that you have imported this line from other software, and so you can create this in here. You can either add a resample node, and here you can see we are resampling the line, and onto the resample we have this attribute to export. So let's enable the tangent attribute, and here you can see we are exporting this as a tangent u. I can make this to an n, and if I were visualize, and here you will see that we have these normals back, and I can change this to v, and same thing, convert all of these into volume and import them in here. Or we also have a node called orientation along curve. So if you add an orientation along curve, and let's add this, and we actually do need to resample this because you know that we are using this Bezier curve, and so we have these weird points. So let's add an resample, and we are just resampling the points. I'm not adding any attribute. If I were to middle mouse button, and here you can see we do not have any attribute. So let's add this, and onto the orientation along curve, we have the option to output the attributes. And same thing in here, we have the tangents. So right now we are exporting our tangents as an AN, and which means I can visualize my point normal. And here you will see, if I zoom in, here we have the normals, or these normals vector. So there are a lot of ways that you can export your tangent attribute, and I'm going to just remove this node graph in here, and maybe let's remove all of these node graph from there as well. And now let's build our very basic pyro simulation. And for this one, maybe I'm not going to use the circle node. Let's also delete the particle fluid surface. We have this basic sphere. So let's connect this in here, and we have the topnet is throwing an error. Let's dive inside. Let's see. We have this pop collision. It's actually referencing to this polywire that we do not have. So let's remove the pop collision. We do not need that. And all of the errors are gone, and these particles have some movement. Let's go into the sphere, and let's build a very basic pyro simulation. And I'm going to create a pyro source node first to create a source. Let's connect this in between, and in here I'm going to say volume scatter, and onto the initialize, let's initialize this to source smoke, and it will create these two attributes. And now we need to convert this into volume. So let's add a volume rasterize attributes node and connect this, and let's rasterize our density and temperature. Sorry, not the p scale, but the temperature attribute. And down here we just need to create a pyro solver node. Pyro solver, connect this in here, and let's hit play. And here we have the basic pyro solver. Let's go into the pyro solver, and let's go into the fields tab, into the shape tab, and let's introduce some of the noises. I'm going to add a turbulence noise, and let's collapse this, and let's hit play. I'm going to adjust this amplitude of this scale, and here you can see right now we do not have much of effect. And let's add a turbulence noise to the density field, and right now we are adding the turbulence to the temperature, and it will get an effect if I were to continue increasing this, because you know we have the temperature volume here, you can see, which means we need to just increase this value, and we should start to see some noise. And here we have it. And let's say that is the simulation that I like. And you know that if we go onto the output tab, here we have the velocity volume. And if I were to middle mouse button, and here you can see we have the 6 grid volume. We have the velocity X, Y, and Z. Right now they are Houdini volume, so let's convert them into VDB, and maybe also enable the 16-bit float. And now if I were to middle mouse button, now we have a vector volume vel. Let's use these velocity volume, all of these velocities that you know that these velocities are moving out this smoke. We can also use this velocity to move our particle as well. So after the pyro solver, I'm going to just connect the pyro solver into the second input of the topnet. Let's go into the topnet and dive inside onto the pop advect. We have the second context, and right now we are looking for the field volume name V, but you know that the DOP will export as an a val. If I were to middle mouse button, it says val. So which means we need to go back and rename this pop advec to the val so that it will looking for the appropriate volume. And now if I were to hit play, and here you will see that these particles are following the path of our smoke. And in here I can play around with my velocity scale. Let's lower this value down, and in here let's shake off this pop wind node. Maybe I can just completely delete this node, and that way we will have all of these noised up information from our this smoke simulation. And here as you can see, I can template my these particles, and here you will see that all of the particle movement, all of the particle forces are being controlled without this pyro simulation, which means I can just continue massaging my this pyro solver. In here I can, let's say, adjust my this scale of the turbulence to create a very chaotic movement. Let's hit play, and here as you can see we have a very chaotic movement. And now if I were to visualize my DOP net of the particles, and here you will see we have the same behavior in here, because now we are controlling our movement from this pyro solver. Let's maybe lower this value down. I think this value is too high, so let's lower this down. And in here let's adjust the sol size. By increasing the sol size I can create these bigger sols, and here you will see that we have these bigger movement. And same thing, I can lower down the sol size, and that we will create a high frequency noise, so we have some smaller breakups. And I can view my smoke simulation, and here we have the smoke, and this DOP net will have a same effect. So that's how you can create your own custom forces and make your particle simulation drive with your own forces. And right now we are actually using this pyro solver. And in here what you can do, if you are going to create you are going to use the pyro solver, first you might need to add a file cache node to write out your caches. So it's a good idea to add a file cache node, and after that you just need to write out your cache. And in here let's go into the pyro solver. If you are going to drive your particle simulation from the pyro solver, we are actually going to need the velocity volume, this val. All of these volumes here, as you can see, we have the 4 VDB volumes. We do not need them. We have the density volume, we have flame volume, we do not need them. So we only need the velocity. So what I can do, I can go into the pyro solver and onto the output, and I can just disable all of these. I do not want to export. So in here I am only exporting the velocity, and right now here I cannot see the velocity volume because it's set to invisible. I can actually make it visualize by the smoke, and right now I can only see the bounding box, but I cannot see this as a fog. But that's fine, velocity volumes are there. You can keep this at invisible, and if you middle mouse button, and here as you can see we have the velocity information. And if you go on to the DOP net, and here you will see that we have the same behavior, because velocity volume is the only volume that we are interested if you are going to drive your particle simulation. And maybe you want to export the density volume for as a visualization, as a guide. And here you can see we are visualizing this our smoke. If you want to export this, but you are not needed to export this density because we are not using this field anyway. So it's up to you if you want to export both of these fields onto your hard drive. So after that, lay down a file cache node and write down your caches, and then you can just use the file cache node to reference your this DOP net. over this particle net, and that will create all of these velocity volumes accurately. So that's how you can use the smoke simulation to drive your particles.